Now, although this is a relatively easy question, I've included it because it's got a really awkward conversion. Okay, so it says the student determined the density of the ring. The density of the ring was 21,500 kilograms per meters cubed. Okay, now in this case, it's good to have it in kilograms per meters cubed because it's asking for the mass in kilograms. Now, because those are both the same, we can tick that part. However, we're given the volume in centimeters cubed, whereas in this case, this is in meters cubed. So it's much easier to convert that to meters cubed, okay, than is to convert this the other way. Okay, so calculate the mass of the ring. So straight away, we write our C FIFA down. Okay, and then what we need to do is do our conversion. So I don't know why I've done that, so I'll turn it into an equals. Now, in this case, if we go from centimeters to meters, we have to divide by 100. Okay, and you remember that because it's century for centi. Now, if you want to go from centimeters squared to meters squared, you've got to divide by 100 squared. But we haven't got centimeters squared, we've got centimeters cubed. So we need to divide by 100 cubed. Okay, and as a result, that gets us meters cubed, which we need to convert it to. Okay, so first of all, that's what we do. So we do our 0.44 divided by 100 cubed. Okay, so we do 0. In fact, I'll do this on there because we're dividing. 0.44 divided by 100 to the power of 3. That gives us 4.4 times 10 to the minus 7. So our answer is 4.4 times 10 to the minus 7 meters cubed, because that's what we need it in, meters cubed. So we're sorted. That's the one that we're using. Now, what we've got to do is use the formula. So this is really easy. We just find the formula for density. So we look down our list until we find the formula for density. So we keep going down until we find it. If it's not on this side, which it is, it's just there, right at the bottom. So we go density equals mass divided by volume. That divided by that times that. So we do that. We put that in our formula. Equals m divided by v. Okay, now what we then want to do is insert the numbers in. So we've got 21,500, okay, equals our mass, which we're trying to work out, divided by a new volume of 4.4 times 10 to the minus 7. Okay, and then all we need to do then is rearrange it. Now, because we're dividing by 4.4 times 10 to the minus 7, if we times by it on both sides, it'll give us m on its own. So we do 21,000, rearrange 500, times by 4.4 times 10 to the minus 7 equals m. So if we do that on the calculator, we've already got 4.4 times 10 to the minus 7. So we can times that by 21,500. That gives us this answer, okay, which is 9.46 times 10 to the minus 3. And they're all in the correct units, because if we remember, okay, that's in kilograms per meters cubed, and they want it in kilograms, so that's fine. That's in centimeters cubed, but it needs to be in meters cubed to match up. So a little bit extra for units when it comes to density to make it easier, okay. So if we've got our mass, we've got our volume, and we've got our density all split up. That means if our mass is in grams and our volume is in centimeters cubed, that means our units have to be grams per centimeters cubed. If our mass is in kilograms and our volume is in meters cubed, that means our units for density have to be in kilograms per meters cubed. And it must be the same all the way along. So if you want to work out density in kilograms per meters cubed, because it tells you or the question might tell you to, similar to this, then you have to make sure your volume is in meters cubed and your mass is in kilograms. All right, hopefully that makes things nice and clear.